Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to integrate by use substitution. We're going to be focusing on cases where the parent function is a rational function. All right, let's take a look at question number 5. We're to find the indefinite integral of the expression 2e to the 2x over e to the 2x minus 4 dx. Okay, so if you take a look at this function, we have a composite function here, which is 1 over e to the 2x minus 4. If you differentiate the inner function of that composite function, you get a multiple of the other function. Let's rewrite this as the integral of 1 over e to the 2x minus 4 times 2e to the 2x dx. So if I differentiate this function down here, do I get that function? And the answer is yes. Okay, so what does that mean? That means that we can integrate this expression using the use substitution method. So our u is going to be the function on the bottom, the inner function. Let's put that in green. Our u will be e to the 2x minus 4. So let's go ahead and differentiate that to get du. Differentiate both sides. You have du equals the derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. Okay, and then minus 0, this entire thing multiplied by dx. So we can clearly see that du equals 2e to the 2x dx. This is a nice problem because du already has a perfect match. We do not have to multiply or divide by any constants to have this portion right here. Okay, so we're ready to carry out our substitution. We'll have the integral of 1 over u, and then 2e to the 2x dx will simply be replaced by du. All right? Now, what is the antiderivative of 1 over u? Using our integration rules, we know that this is going to be the natural logarithm of the absolute value of u plus the constant c. To finish up the problem, we're going to plug in the value of u back into this expression. U is e to the 2x minus 4. So our final answer will be the natural logarithm of the absolute value of e to the 2x minus 4 plus the constant c. And there goes our final results. Go ahead and box that. All right, let's take a look at question number 6. For question 6, what if we were to evaluate the indefinite integral of the expression 20 cosine 4x divided by sine 4x dx? Okay, now let's go ahead and separate the function, because if you notice, we have a rational function here and another function on the top. So we can write this as the integral of 1 over, we have a rational function composed with a trig function, sine 4x, okay, times 20 cosine 4x dx. Now, if you differentiate sine 4x, do you end up with a multiple of cosine 4x? The answer is yes. So we can use u substitution here. Okay, so we're going to call u sine 4x. Okay, then differentiate both sides to see how to find the u. So we have the u, derivative of u is just 1 du. Here, the derivative of sine 4x is cosine 4x, using the chain rule, times 4 dx, of course. Okay, so we have du equals 4 cosine 4x dx. Are we ready to substitute? The answer is no. Well, why not? Du is not a perfect match. Du is 4 cosine 4x dx, and here we have 20 cosine 4x dx. So how are we going to resolve the discrepancy? To make this right side match 20 cosine 4x dx, we'll simply multiply both sides by what? By 5. Okay, so multiply this by 5, and multiply that by 5 also. So we're going to have 5 du equals what we want, which is 20 cosine 4x dx. Now we're ready to substitute, okay? This integral that looks so complicated now becomes the integral of 1 over, instead of sine 4x, it's going to be 1 over u. 20 cosine 4x dx can simply be written as 5 du. Okay? Now let's factor out the 5 before we integrate. So we have 5 times the indefinite integral of 1 over u du. Now the integral of 1 over u is the natural logarithm of the absolute value of u. So we have 5 times the natural logarithm of the absolute value of u plus c. So we know what u is, right? U is sine 4x. So our final answer will be 5 times the natural logarithm of the absolute value of sine 4x plus a constant c. And there goes your final result. Okay, let's take a look at problem number 7. So for problem 7, what if we're asked to find the indefinite integral of 2 divided by x times 2 plus the natural logarithm of 4x dx? If we take a look at the inner function of the composite function 2 over 2 plus ln 4x, if we take the derivative, do we end up with a multiple of this function right here, 2 over x? To make it easier to see, let's go ahead and split this functions into 2. So what if we write it as the integral of 1 over 1 over 2 plus the natural logarithm of 4x, okay? And then that times 2 over x dx. Now if I take the function at the bottom here, and if I find the derivative, do I get a multiple of this function here? And the answer is yes. Okay, let's go ahead and show why that's the case. So we're going to extract u. Let's call u the inner function of the rational composite function, which is 2 plus ln of 4x. If you differentiate this, du is going to be 0 plus. Now we're going to use the chain rule here. ln u, the derivative of ln u is 1 over u, but u is 4x, so it's 1 over 4x, times the derivative of 4x, which is 4, this entire expression dx. Okay, these two 4's divide out, so we have du is equal to 1 over x dx. Now, are we ready to substitute? The answer is no. Notice we have 2 over x dx here, and then this is just 1 over x dx. So either we can factor this out, or we can multiply both sides here by 2. Okay? So let's go ahead and just multiply both sides by 2, multiply this by 2, multiply that by 2. So that yields a u that we can apply directly. So we have 2 du equals 2 over x dx. That's exactly what we want. Okay? So this integral now becomes the indefinite integral of 1 over u. U is, 1 over u times 2 over x dx is 2 du. Alright, so we'll make our substitution. That becomes 2 du. Now we can factor out 2 before we apply our integration technique for ln. So we have 2 times the indefinite integral of 1 over u du, and that's going to become 2 times the natural logarithm of the absolute value of u plus c. Okay, now what is u? U is 2 plus ln of 4x, so if we apply that here, we have 2 times the natural logarithm of the absolute value of 2 plus the natural logarithm of 4x plus c, and that is our final result. Okay? All right, let's take a look at problem number 8. Now, what if we have to find the indefinite integral of negative 12x divided by 2x squared plus 3 dx? All right, now if you take a look at this inner function of the rational function 1 over 2x squared plus 3, if you find the derivative, you end up with a multiple of 12x. The derivative of this is 4x times 3, you get 12x, so the answer is yes. So we can, to make it obvious, to make our next step obvious, let's break it up. We have the integral of, we can factor out the negative, put the negative there, let's not forget that, minus, and then we can break up the two functions. We have 1 over 2x squared plus 3 times 12x dx. Okay, now if you differentiate this, do you end up with a multiple of that? The answer is yes. Let's go ahead and illustrate that. U, the inner function of the composite function here, is 2x squared plus 3. All right, if you differentiate that, du is going to become 4x plus 0 dx, right? So we have du is 4x dx. Now, are we ready to substitute? The answer is no. Why not? Du is 4x dx, and we have 12x dx here. So how do we make the right side of what du equal to the same as 12x dx? To accomplish that, we'll just multiply both sides by 3, because 3 times 4 is 12. Okay, so we are going to have 3 du, let's change the color, 3 du is equal to 12x dx. That's exactly what we want. All right, so now let's go ahead and make our substitution. So when we carry out our substitution, it's going to look much less complicated. So let's not forget our negative, the indefinite integral of 1 over u. If that's u, then 12x dx is going to become 3 du. Okay, so 3 du. All right, now let's factor out the 3 so we can integrate 1 over u. So we have negative 3 times the integral of 1 over u du. Okay, so the antiderivative of 1 over u is ln u. So this is going to become negative 3 times the natural logarithm of the absolute value of u plus c. Okay, now if you plug in the value of u back into our antiderivative, we're going to have the final result, negative 3 times the natural logarithm of the absolute value of 2x squared plus 3 plus the constant c. And there goes your final result. Thanks so much for taking the time to watch this presentation. Really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.